everyone, in a video that follows this one in the folder, I've got a demonstration of Tower of Hanoi that's available online. As most puzzles like this are, you can actually Google "math is fun, Tower of Hanoi," comes right up. But the idea is, in this notion of working backward, I want to establish sub-goals as I have in the Tower of Hanoi. And what is that goal ultimately? Is to have all rings on the right peg and move them one at a time in such a fashion that a larger one is never on top of a smaller one. And that can be done in 7 moves, as you'll see in that video. It lasts a minute and a half. But the sub-goals would be, well, gosh, the first goal is I must move the top ring away from the left peg somehow. Now, I don't know whether it's going to go on the middle peg or the right peg, but that must be moved. And you can see that live demonstration as I have it on a following video. This can be done in as few as 7 moves, but it took me 13 because I'm up there in years now at age 54. But anyway, working backward is most effective when the backward path is unique, which makes the process more efficient than when working forward. So as you may have noticed, working backwards shares something with means and analysis, the technique of reducing differences between the current state and the goal state. And now in this case, it's really defined. You want to talk about a well-defined problem. The rules are very direct, and the violations of those rules would be very apparent for what it's worth. So in this case, it can be done in 7 moves. You can, and as simple as this says, you can nearly visualize it. It can get more complicated when you have 4 rings and 4 pegs. In that case, of course, it takes many more than 7 moves. But the, what do they call it? The recursive strategy is pretty direct. So in working backwards, I'm beginning with sub-goals and starting with the end in mind with this idea of working backwards. So it's most effective when that backward path is unique, which makes the process more efficient than working forward. And as you may have noticed, that it shares that idea of reducing differences between the current state and the goal state. I encourage you to look at my little brief video. It's from mathisfun.com, and you can get good at it. And by the way, I think maybe on that software, you can increase the number of pegs and increase the number of rings if you're into that sort of thing. I think it's kind of fun.